Now, if you've got any questions or anything like that, yeah, feel free to ask as we go along. Like I said, we have covered, or you have covered a lot of this before, so it should be hopefully okay. There's some terminology and stuff that we need to get used to, but for our sequences and series, the first thing that we're going to say is a sequence, and I apologize if this is really obvious, is a list of numbers that follows a pattern. And sequences can be finite. What do I mean by finite? Yep, or infinite, which means, yeah. So, for example, the sequence 7, 3, 5, 1. What am I doing here? Subtracting 4. I can't count. Okay, so the first sequence here is finite or infinite? It's finite because it doesn't have 3 dots. Finite, infinite. Finite or infinite? Sorry. Infinite. Finite. Finite. Infinite. Infinite. And the second one is infinite because it's got 3 dots. Okay, so that means it keeps going on forever and ever and ever and ever and ever. Doesn't stop. Okay. Right. A term in a sequence is denoted by, do you remember what notation we used for like any term in a sequence? Not N. U, good, U, N, okay? So that's U with a little subscript N. I do not want to see this type of thing. Okay? I want U with little subscript. So this means, so if I've got UN, this is essentially the nth term in a sequence. So for example, who wants to give me a sequence? Give me a sequence, someone. 2, 4, 6, 8, 10. Let's make it infinite. So 2 is the which term? First term, so that's U1. 4 is the second term, which is U2. U3, U4, U5, and so on. U6 would be? Yeah. All okay so far?
Yeah.
Good. So a formula which can describe the sequence for the general term called UN. So it's the nth term, okay? UN will be the formula. Is that what you kind of looked at last year? Okay, cool. Good. All right. So we're going to be looking at two types of sequences, arithmetic, which you're used to, yep. Geometric, you did some stuff on. Excellent. So let's just have a look at arithmetic sequences. If I go too fast, please just let me know. If you want me to slow down, that's fine. I know I have a tendency to rush. I just get so excited. Don't mind if you want to eat. Are you kidding me? What are you doing?
I'm just trying to make her lines equal. She's annoying. She's gonna do arithmetic on one side and then it's like a subsection of a column.
Why?
I just like two columns for the two types of sequences.
I'm just going to do arithmetic first.
Yeah, she's putting that on one side and then
once we get to geometric one day,
you're going to go back?
Right
okay.
there.
All right. Okay, so arithmetic sequences. So tell me about an arithmetic sequence. How do you know a sequence is arithmetic?
When the second whatever thing is
When
like
the next
plus 3.
term can be added by a common value.
Right. Okay,
Wow.
good. Can anybody improve on that? That's technically okay. That's what you said.
The general term
Right.
it uses addition instead of
Okay.
UN plus.
I think you're overcomplicating things. What makes a sequence arithmetic? It has a what? It's got a, now Maya used one word, she said common, but I didn't like the other word she used. It's got a common,
jump.
not factor. What's
D, it's a D.
It's a D word. Difference. It's got a common difference, okay?
I got you there, so you're welcome.
Okay, so arithmetic sequences. Always have a common difference. And it can be positive, it can be negative, it can be a fraction. So for example, the sequence 3, 7, 11, 15. The common difference here is this. I'm adding 4 each time. And the important thing to notice here, okay, we denote common difference with the letter D. I know this is all obvious, but just want to get it all down. So, generally speaking, who can give me a little formula for what D is equal to? Now, there's different answers to this. Nope, generally speaking. Right, U2 minus U1 will give me a value for D. You can give me another example. Right, U3 minus U2. So if you subtract any two, what's the word I'm looking for? Which terms? Because I could subtract, consecutive terms, it will give you the common difference, okay? So consecutive means that it's one after the other, okay? So subtract any two consecutive terms, you get the common difference. And so on, okay? That's quite important. Also, just 7, 4, 1. The common difference in this case is -3. Okay, so now we need to come up with a finding the nth term for an arithmetic sequence. So this is finding a formula. Now, I'll just put a line under this. Does anybody remember the formula from last year and how to do this? Yes, Sam?
This is just what my reference is. Do the u n equals u n plus 1 minus 3. Is that right?
Not quite. So let's actually figure it out, okay? Let's figure this out from scratch. So the first term in any sequence is? Okay, u1, okay? I wouldn't write this down just yet, okay? Because I'll probably make a big mess. And then I'll want to tidy it up. First, second, third, fourth, fifth, dot, 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 dot. And then we've got n. So these are our terms. And then for our sequence, okay, we said the first term is u1. Now, what is the second term? It's u2, right, but in terms of u1, what is it? u1 plus d, okay, because it's the first term plus the difference, okay? Now, if we want to think of it in numbers, let's imagine the first term is 3. Let's imagine the first term is 3 and the common difference is 5, okay? So 3, to get the next term, we do 3 plus 5 is 8. Okay, what would the third term be? It would be 13, so how are we getting that in terms of our general formula? We're adding on another d, so how many d's are we adding on? 2d, right, so u1 plus 2d. What about the fourth term? Yeah, because you're adding on another common difference. So that would be plus 3d. So if I do, so it's 3 plus 5 plus another 5 plus another 5. So that's 3 lots of 5, yeah? 3 lots of the common difference. And then for the fifth term?
40.
Yep, that's 4 lots of the common difference. So 5 fours are 20, so that's 23. So looking at the pattern here, you're all good at your patterns, your criterion Ds for your MIP. What's the pattern between the terms and the actual sequence? What's it going to be, Sienna?
U1 plus U... Wait, no, hold on. U1 plus UN minus 1. No.
Almost.
UN minus 1. UN minus 1, no.
U1 plus n minus
N
1,
minus 1.
because it's always 1 less. If it's the fifth term, it's 4 times d. Right, good. And let me tidy that up. Get rid of that. So these are our terms, and this is our sequence. And I suppose you could say this is our general sequence. And this is it using actual numbers. So our formula for un, for the nth term for any sequence is u1 plus n minus 1 times d. Did you see that last year? Okay, good. Now the good thing is you do not need to remember this. This is in the formula booklet. No, I haven't given them out yet, don't worry. Okay, I'll print them and give them hopefully on Monday. But it is in the formula booklet, you don't need to remember it, and which is handy, but you'll use it so much that it will become ingrained. Okay, so you can kind of, if you get that written down for me, that would be great. Does that all make sense for how that formula comes about? Sweet. Okay, so just to show you how this works, we're going to, for these particular sequences I'm going to write down, I want you to find the general term. So remember, the general term is just formula, okay? It's just what the formula is for UN. I'll look at the first one with you. So we've got 5, 13, 21, dot, dot, dot. 40, 32, 24, dot, dot, dot. And then let's see how good our fraction skills are. 1/2, 5/6, 7/6, dot, dot, dot. Okay? Do you want me to do the first one with you, or do you want to? Yeah? Okay, so the good thing about this formula is it will always work, okay? Now, there's other ways to work this out that you may be used to, which is fine. The formula is pretty sweet. So you start with the formula, UN equals U1 plus n minus 1 times d. You're looking at your numbers, so remember, I want the general term, so it's going to be UN equals. Safia, what's U1 in this sequence? Yep. And because it's a formula, I have to have my n in it. And then, Maya, what's d in this sequence? 8. What's this 8 doing to this bracket? Multiplying, so I'm going to multiply it out. So I've got 8 times n is 8n. I've got negative 1 times 8, so I've got subtract 8. Okay, so I'm just expanding that bracket, is that cool? And then I can just tidy it up. I've got 5, take away 8, which is negative 3. Why am I in a different color? So my general formula is negative 3 plus 8n. Okay, so that's my general term for this sequence. And the good thing is, if I wanted then the 100th term, what would I do? Substitute n for 100, right? So that just out of interest, the 100th term would be negative 3 plus 8 times 100, negative 3 plus 800, which is 797. Okay, so the 100th term of this sequence would be 797. Does that make sense? Is that cool? So do that for the other two. Don't mess up your fractions. We'll go over them in just a second. Guess what? 18th of October has been declared a public holiday to recognize and celebrate Flora Duffy's success in the Tokyo Olympics.
Like forever, or just like this year?
I think maybe just this year.
Is that a Monday or a Friday?
I don't know. Oh, I hope it's a Monday or Friday.
Yeah, me too.
18th.
I'm not gonna.
If it's Tuesday, they'll give you the Monday off.
Oh, that's true.
It's a Monday.
Pretty good.
Nice.
Pretty good.
Yeah, thanks,
Yeah.
Laura.
Try and win some more.
I thought school. I thought you were gonna say that school was canceled.
Yeah.
Like, why would you be? Because like everyone's. I know. I don't know.
Again, so the B was it's hopefully not too bad. Thing is to remember that when you're multiplying this out, it's -8 multiplied by these things. So it's -8 multiplied by n, which is -8n. Negative times a negative is a, so it becomes +8. So my final one is 48 minus 8n. Good. Right, now for the last one, don't let yourselves get all flustered by fractions. We've got 1/2, 5/6, 7/6. To work out, well actually I'll start off with the formula. First term is 1/2. I'm just going to write 1/2 plus n minus 1 times d. Now what is the common difference here? 2/6. Okay, and the easiest way, rather than looking at the first two terms, I'm just going to look at these two. Because 5/6 plus 2/6 is 7/6. Okay?
On second.
No, 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 no.
No, I went out of my way to do one half.
Yeah,
Yeah, me too. Yeah,
But you still got two, you got a third?
I need both of them.
Always-
Oh.
Always look for the quickest way, okay? Always look for the quickest. And the more you do it, the easier it'll get.
It just feels like when we have to do two things together.
So we multiply out our brackets. So I've got 2/6 and minus 2/6. Everything is in sixths here, so I'm going to change my half to how many sixths? 3/6. What is 3/6 take away 2/6? Good. So UN equals 1/6. What is 2/6 simplified? There we go. Okay, so that would be our general formula. Okay. All right. Excellent. Good. Is that the way you would have gone about these last year, using the formula, or? Okay. Good.
I couldn't be able to.
Okay, right, here is another question for you. I want you to find the number of terms in the finite sequence.
Oh, well, no.
So the number of terms in this sequence, I've got -8, -4, 0, ... 36. So how many terms are in this sequence? Now, the thing with these questions, if you stick to the formulas, if you use the formulas, you are always going to have a good chance of getting these correct. So start with your formula and then put everything in that you know, okay? So start with the formula. I'll even write the formula down.
We should do the formula.
Start with the formula, yep. Because you know what U1 is, I know what D is, I know what the nth term is.
Oh, okay.
The nth term is the last term in the sequence. Yeah.
Oh.
And I can then go work backwards to find out what n
I thought
is.
the nth term was just like whatever term you wanted it.
Yeah.
Well, it is, but in this case, it's the
Oh, but we want it
It's-
to be
it's-
36.
Yes, we
Okay,
want it to be
yeah,
36.
But we
Yeah.
want to find
term
out
doesn't
what
Because
mean
you
the
want to
last
find
Right.
term.
N is like
Yeah.
what?
No, I know what n is.
we're looking for n and we're looking for the last term.
Okay.
Yes, but n isn't the last term. But right now,
In this one, it
Okay,
is because
yes,
it's
yes,
finite.
yes, yes,
In this sequence, it's finite. Oh, and then we'll do this one. This is nice.
No, we changed it to run UN or 36. No, but I also can't wait. That's fine. You can do that too. So many things in there. That's why you can solve it. This is the amount of cards. Yeah.
No, you can't have it.
You find what n is, so you go.
Because it's finite. So
N was the 36? No, UN is 36. The nth term is 36.
Oh,
N.
You're finding what n
yeah.
equals.
N is number
Like-
of terms.
The blah blah
So
blah
you're finding
term
out-
could be 36. Like, is the nth term
So
the
if you
18th
think,
term?
looking at this, -8, that is the first term, U1, yep. So that's term number 1, you can think of it as, yeah? So that's when n is equal to 1, first term. -4 is U2. That's when n is equal to 2. This is U3, that's when n is equal to 3. This term, I don't know what n is equal to. I don't know what number along here I have to go, yeah? But I know that un is that value, 36. U3 is 0, U2 is -4, and so on, yeah? So I need to figure out what n is. Yeah.
Oh, because n isn't 36.
Exactly, yeah. N is the kind of position along it is.
So n is like 36 plus 4. No, that's so wrong. Don't. I didn't say that. Nope, that's really not what the answer is. It's so. I was just confused.
Okay. I
Okay.
don't know where the time came from.
No, because there's 3 terms. Don't listen to me.
Okay. You did the math.
Yeah, I will.
How's everyone doing? Layla, you good? Safia?
Yeah, 24.
So I think it's really useful, like to think, okay, U1 is the first term, which is -8, and that is when n is equal to 1. U2 is -4, that's when n is equal to 2. U3 is 0, that's when n is equal to 3.
What is wrong with me? You like dinosaurs?
Yeah, who doesn't? And then
There's all the dinosaurs up there. I got 36 equals 132. What does that
Okay.
mean? Like, what am I telling
Let's have a look, let's have a look. Give it back, Bella. Bella, give it back. All right, okay, looking at this, paying attention, come on. UN, okay, so UN is 36, okay?
Yes.
U1 is -8. N is what we are trying to find because we want to find out how far along here we are going. We know that D is what?
4.
+4, right. So I am solving this for N. So I've got 36 equals -8 plus 4 and -4. 36. -8 take away 4 is? Good. I add 12 to both sides. Is that okay?
Add 12. Okay, that's where I'm
Yep, because you got -12. To get rid of the -12, you have to add it. To get rid of the 4 in front of the n, you have to by 4, and you end up with n equals 12.
I almost got it.
Okay, so that tells us that if we go 12 kind of terms along, we will end up at 36. So don't get confused about n and un, okay? Un is the actual number in the sequence. N is the number of kind of spaces that you move along to get to it, okay?
See, my problem is that I put the 36 as n.
Okay.
And I also put the 36 as un.
You can think of it as, see these n's? N's are like your house numbers, okay? If you're going down a street and they're all numbered 1, 2, 3, 4, 5, 6, 7. And then these are the people that live at them. So in house number 1, we've got -8 lives there. In house number 2, -4 lives there, and so on, okay?
Yes. This is like, yes.
You sure?
This is like, yes.
Okay, last one for today. E.g. whatever, I've forgotten. What are we up to, Bella?
Page 3.
E.g.
Total EG or of this?
3.
Okay. You should write numbers for any of the other ones, but.
Did I not? Okay,
Nope.
then scrub it. Okay.
Where did that come from?
You used to have 3, but not
That was,
this year.
that was a bit ago.
2 terms.
Yeah.
In an arithmetic sequence.
Oh no. Why?
R, so we've got U6 equals 4 and U11 equals 34. What I want you to do is find U15. You can use the formulas to do this. There's other ways you can do it. Do it however you want to try and do it. And
So if we look at the formula, would I be trying to find u sub d, or am I trying to find d and then u sub d?
you're going to need to find D first, yeah. If you want to do it like that.
So if I don't know what u1 is,
Correct.
then I can't use the formula to find u.
So you can come up with a formula for this one, yeah?
Uh-huh.
You can come up with a formula for this one.
Yeah.
And you're going to have how many unknowns in each formula? 2, because you don't know what U1 is, you don't know what D is. So if you've got 2 formulas with 2 unknowns, what can you do?
Oh,
What can you do?
the simultaneous.
Yes! Yeah, you can do it like that.
I've got to
I'm
do
just
it.
gonna
That's
count.
one way you can do
I'm
it.
gonna count spaces.
Or you can count spaces.
Wow.
I'm trying to do it that way.
I'm gonna.
Because you know this is going up by the same amount each time.
No, help.
Is it d6? Wow.
You know it's going up by the same amount
You
each
should just
time.
do 30 minus wait, 30.
I think it's
I know,
No,
but
but
I
I
think
think
oh.
I mean 11 minus 6 is 5, so 30 minus 8.
Alright. That's what I did.
Yeah. And
Oh, that's what you did.
And then you can do exactly
What?
for
Okay,
each
then.
15 minus 11.
Okay, so you didn't do an equation. Use the formula.
Yes.
You didn't use
And
the
then you
formula.
went for
Yeah,
what?
You used the formula. You said actually do it. You usually
I
do
did
it.
that. I did what we just talked about.
You didn't do it. You went.
And I'm from base in this class.
That was like the real way to do it.
So-
No.
You know this is going up by the same amount, yeah?
Right.
So how many gaps are there here? There's 1, 2, 3, 4, 5, yeah?
Nope. 84. I did.
Oh, I said 30 divided by
Hold on.
6.
I think it's 8.
30 divided by 5, because
Five.
it's 5 gaps. Yeah,
It's
34
84.
take away 4, 30. Divided by 5 is 6. Let's test it. So 4 plus.
D6?
Yes,
Okay.
because
Oh,
it's
okay,
going
okay,
by
okay,
6
okay.
percent.
You're 16 minus 84.
Nope, nope, nope. You didn't
What?
get faster than well, I was talking to Bella the entire time. And also, you figured it out faster than me.
That's actually the only thing I remember.
Because the only thing I didn't like.
All right, listen up for 1 second. Listen up for 1 second and then I'll let you go. So I want you to get this question finished. I know a lot of you have finished it. There are questions that I want you to have a look at on page 16 of the book, okay? And this is exercise 1E. Alright, I want you to spend, yep, I want you to spend about 30 minutes having a look at those, okay? And then the way this works is you come in on Monday, and if you're saying to me, I had trouble with question 7, then we'll have a look at number 7. If you say that I struggled with question 1, then we will have a look at question 1. As long as you try some of them for a good 30 minutes over the weekend, and if everybody says they had no issues with anything, then we move on, okay? So I'm requiring you to keep up with it, okay? And we'll finish this one off. If you haven't finished it, we'll look at it again on Monday, okay? Good job, everyone.